Welcome to the Plasma Protein Therapeutics Association's webinar, Introduction to the Global Journey of Plasma. I'm Julia Fabens, and I'll be moderating today as we hear from experts about the complex global process that plasma follows as it becomes finished therapies. These therapies treat patients with chronic, often life-threatening conditions around the world. I'm joined today by Chuck Borders, Head of Quality at BioLife, who will give us some insights into the plasma collection process gleaned during his 20-plus-year career with BioLife in a variety of quality control and assurance roles. Michael Schroeder, Senior Vice President and Site Head at CSL's Marburg facility, will give us a look at the fractionation process. He too is a seasoned expert who actually started in CSL's apprenticeship program in 1988 and has held a number of roles throughout the company. And finally, we'll have Matthew Hochko, who's President of the Marketing Research Bureau and a noted industry data guru with a similarly long history with the plasma protein therapy industry. And he'll give us an overview of how those pieces come together to create a global industry serving patients. As you listen to the experts today, please submit any questions you have through the Q&A box, and I'll post those to the panel after the presentations are completed. We'd like to make sure there's plenty of time for the panel to take questions, so without further ado, I'll welcome Chuck to start his presentation.
Thank you, PPTA, for allowing me to present on the journey of plasma from the donor to the fractionator. Over the last 10 years, there's been a tremendous amount of investment across the plasma value chain, from donor centers to fractionation capacity, all the way through the commercialization, all the way through to the patients. As well as an investment across the R&D spectrum for plasma products. We'll begin the journey with the donor acquisition and donor engagement for the process. And this is usually done through either traditional marketing, television and radio, direct mail, billboards, or print ads, or more recently, online marketing, such as Facebook, Twitter, and as well as email engagements. There's also in-center marketing that creates awareness through posters, connection to the patients, as well as signage on upcoming payment programs. One of the things that's important is to ensure that the plasma centers are engaged in the community to create awareness, as well as excitement and purpose for the plasma donations throughout the network. You can see through the donor websites and portals, through mobile, different videos, informational videos will allow to donors to engage before they ever walk into the center. Expanding our services to meet the needs for today and for the future is allowing us to address the growing demand for plasma therapies, and it requires focused investment in the plasma collection process. Improving the donor experience through multi-channel or omni-channel engagement from the donor app or mobile app to scheduling, online scheduling, as well as payment and communications through the website. Attracting donors in the community through reaching out to them through different channels, encouraging community engagement, and increasing the supply of plasma throughout expansion of new centers, expanding into new markets, and improving existing and changing regulations. Creating awareness throughout the process and messaging is important to gain plasma access and donors availability. We continue to look for new ways to engage the donor, so that donors have a great experience when they spend their time in the center. Briefly, I'll review the plasma donation process. It starts with the registration, then full-length donor questionnaire, physical and screening, as well as the phlebotomy and donation process. These are all underscored by the standards from PPTA in regards to the community-based donor standard, the National Donor Deferral Registry, cross-donation management standard, and donor education, as well as personal education and training and quality assurance, all to make sure the donor's experience is a safe and effective and a positive one. As you can see on this slide, the general regulatory requirements for plasma donor eligibility are fairly similar across the US for US source and recovered. And there are some minor changes based on country in the European countries, as well as the rest of the world. Screening and eligibility criteria are essential for donors and patients. Our strict eligibility and screening standards ensure the safety of the donor and the patients. This criteria makes sure that everybody has been established by global regulatory authorities. Centers have been staffed by medical professionals with specialized training. And once eligible, donors can participate as often as local regulations permit. The donors, like I said earlier, receive medical history screening as well as undergo a physical examination required by local regulations. Here's an overview of the plasmapheresis process. The plasma is processed outside the donor through taking the red cells out, spinning those down, and then separating the plasma and returning the red cells back to the donor. Afterwards, after the process, the donor will receive saline solution to help create a positive experience. After the unit is collected, samples are sent on to testing to centralized testing laboratories. Here's the process flow of the sample's journey from the donor center to the testing lab, and the data of the results returning back to either the donor center or the warehouse for unit processing. Here's an example of two of the testing labs within our network. And you can see the equipment as well as the scale here. And every donor is tested for serology. Every donation is tested for NET. And every donor is tested for donor qualification testing up to 3 times a year. Moving on to the plasma flow, the plasma leaves the center on refrigerator trailer or a freezer trailer to the central warehouse. Meanwhile, as everything's taking place in the background, the data is following the plasma unit to that warehouse. At some points, the plasma is cross-docked and then shipped overseas for further fractionation. Here's some examples of the technology used in the logistics or the supply chain. We have a freezer container. We have a freezer trailer that reaches -20 or colder. We have satellite tracking. We have fleet management software, as well as cellular and digital temperature monitoring devices. Once the plasma arrives to the storage facilities, it is stored in the warehouse at -20 or colder, and then is processed in a cold room at -5. Usually it's processed by automated plasma dispositioning systems that sort the good units and then will disposition any units that have a look back or a positive test result associated with them. Here's some examples of traceability through the supply chain in regards to barcodes, RFID technology, inventory hold, unit traceability, as well as unit batching. The logistics and interface flow and data flow is a complex one, but it's all necessary to make sure the plasma is released on time and is released in the right order. As you can see in the pictures below, here's some examples of the automated dispositioning systems and lines that are used to process the plasma. All plasma follows strict testing and removal procedures of our safeguard our therapies from potential pathogens. Rigorous plasma screening processes to ensure a healthy pool of plasma for therapeutic use. Each sample is tested for each donation and sent to the laboratory and rigorously tested for indicators of viral infections. And then finally, the last step in the process is plasma products are further safeguarded by advanced pathogen reduction processes. All plasma centers, whether they be in the US or globally, are inspected at regular frequencies. Here's some examples of those frequencies. In the US, US FDA, EMA, PPTA, CLIA, as well as many state agencies. and you can see the frequencies associated with those inspections. This year, based on the COVID pandemic, the inspection process has went under some changes and to ensure that the plasmas could still be processed and sites could still be inspected, including on-site inspections, desk and document requests, or paper-based inspections, virtual or video conference inspections, and hybrid or limited hours on-site inspections, all to ensure that the products that are collected are safe and the donors have a positive experience. In summary, plasma centers are vital contributors to the local communities. The staff is committed to the well-being of our donors. Engaging with our donors builds a sense of community and awareness. IQPP standards ensure the safety and quality throughout the collection, testing, and release process. And digital technology is advancing throughout the supply chain. Plasma products are further safeguarded by advanced pathogen reduction processes. I would like to thank all of our donors for their commitment to donation and making an impact on patient lives. I'd also like to thank all of our employees across the industry for their hard work and effort, especially through the pandemic, to make sure product is available for the patients that need them.
Now that Chuck's gotten safe, high-quality plasma to the fractionation facility's door, let's let Michael take it from here.
Happy to be here to give you a further explanation on the exciting journey the plasma is doing. Thanks to Julia for the nice introductory words, and thanks for you, Chuck, what you explained about the plasma collection around the globe. So first of all, I would really like to echo what Chuck had mentioned. We need to thank our donors. We need to thank the employees at our plasma centers, at our fractionation facilities on the ground to deliver the products to our patients. We are really in a people-to-people business. We have people which are voluntary donate plasma. We have people in our companies who take care of this highly treasury of this plasma and produce life-saving therapies, which we then distribute to our patients. And they are also people. So we are in a people-to-people business. I would want to give you a short introduction about CSL, the company I work for. We have a global network available where we collect plasma, where we do the further production of the final products, distribution into over 100 countries in the world. And these are some numbers about our company with over 27,000 people working for us globally. So, and what will I present? So we had heard from Chuck what is the effort to collect a liter of plasma, all the tests we perform, the logistics behind shipping this plasma around within the networks of the different companies. And then when we receive this plasma, we have further manufacturing steps. So I splitted my presentation in those main parts of the manufacturing process, starting with the base fractionation, going into bulk manufacturing, going into the aseptic filling, the visual inspection, and packaging. And after that, the products are distributed to our patients. Before we go in the details of these various steps, I would really like to show you one slide in advance of this to honor here a little bit Professor Cohn. He was one of the main inventor of this plasma fractionation. So there was a need to look through how soldiers on the battlefield could be served with albumin to therapy shocks. And here it was developed the process of plasma fractionation. And what Professor Cohen had developed with his team was then implemented in the industry and further developed, further improved to come to the stage where we are as of today. So the first step within the process of the plasma fractionation is that we have we pool the plasma, which we get delivered from our plasma supply chain, into a bigger volume. So a plasma donation is roughly 900 milliliters, and multiple of those plasma donations we are pooling together. And then we start a cascade of various process steps to further purify and put those specific plasma proteins, which are the targeted proteins for the life-saving therapies, to purify them to our final products. And the first steps are those plasma fractionation, starting with different techniques. The first storageable intermediate we harvest is the so-called cryoprecipitate, which is then further processed into various products. Then we do also some other purification steps to receive other targeted proteins in an intermediate, storageable intermediate form. And that could be hemophilia B, bleeding factor 9, or that could be inhibitors, which are used for various products, immunoglobulins for immune deficiencies or others, then our factor fraction 4 and fraction 5. And in the base fractionation, this process is mainly done with temperature, pH, and alcohol concentration, which is used to get a precipitation and then harvesting the targeting proteins. And when we have those storageable intermediates, we then move into the next steps where we do the further purification of the target protein to produce our life-saving products. This is called the so-called bulk manufacturing process. And what we do here in the bulk manufacturing process is we take this storageable intermediate, which we harvested or out of the initial base fractionation, pool them together, and then do further process steps to further purify the target protein. And those purifications, for a little bit bigger, what you could see here on the left side is the alcohol fractionation, which based on the original development of Professor Cohen. Then in the middle, you see there are various techniques available to further purify the target protein. You do precipitations, adsorptions, chromatographies, what Chuck had already mentioned, multiple virus inactivation steps which are involved, filtrations, or centrifugations. And those different techniques are put in a certain sequence to clean, to purify the target protein more and more and more, and have then finally the target protein in a specific formulation available. And when we have those target proteins formulated, then the aseptic filling starts. So aseptic filling, for those people never seen this, looks like that there are people which are flying to the moon, so they are really covered fully. The target here is really to hold everything as clean the air as possible, and do those fillings. And then we have different presentations. Some of our products are delivered in a liquid form. So that's, for example, albumin, immunoglobulins, which are filled and delivered in a liquid formulation. Other products we have, like some of the hemophilia products, which are so-called liable proteins, which are not very stable in solution, we need to freeze dry them. So freeze dry means we need to get rid of the water and have a little powder available, which then gives the product a longer shelf life. The negative point on it is that when the patient wants to inject the product, then they need to dissolve the powder again with so-called sterile water for injection. It's an extra step, but without this step, it would be not possible to have a certain shelf life for those products. So when this filling is done, one is in liquid formulation. The other opportunity is to have it in this freeze-dried formulation available. Then an important step happens, the so-called visual inspection. So that's done manually, semi-automated or fully automated, where we need to check that the product is perfectly assembled. And then the last step in the chain is, oh, yep, that was one slide too much, sorry for that. The last step in the chain is packaging. What we do here is we then assemble the products for the different countries in the packagings. We put in the, as mentioned, the WFI or transfer kits or other things. And we as CSL deliver these products in more than 100 countries in the world. And each country, or a lot of countries, have their specific requirements, how to pack, what needs to be put on the label, what needs to be put on the packaging insert. Then serialization, which is a big theme here on packaging, which gives the opportunity to have a traceability. That was also what Jack mentioned. We have a traceability from the final product, really from the final vial of product back to the donation. So we could really trace backwards from the product to the donation, in which donation center, which donor had donated this product. And this traceability is very important. So that's the next steps. And you could see what is really here. There are a lot of steps necessary to come from the collected plasma to the final product, which is then delivered to the patient. And I could really reinforce this. We are in a people to people business, and that's something you need to remember every time. We have people who voluntarily donate their plasma. We have people in the industry working here and taking care of the treasury and producing those life-saving therapies. And then we deliver those products to our patients. Thanks. And Julie, it's your turn.
Now that we've got a great picture of these two halves of the process, we're going to have Matthew put them together for us with an industry overview. Take it away, Matthew.
And the PPTA for allowing me to share a little bit of the high-level look at this industry with my presentation on the flows at the global level. My name is Matthew Hotchko. I'm president of the Marketing Research Bureau, and we are a company that covers and provides data and market intelligence on the plasma proteins industry. And so for this presentation, I will be showing you data that my company collects, and this is information that we do and have to share. So I really want to talk about, on a high level, three main points, which is to show you some information and data on where plasma is collected around the world, as it is not equally distributed around the world. And then talk a little bit about how plasma needs to go from where it is collected to where the factories are, the fractionation plants that produce the products that Michael spoke about earlier. And then finally talk a little bit about two of the key proteins, immunoglobulins and albumin, and how their usage is around the world, and therefore from the plant where the products must go to reach the patients who need them globally. First off, I want to show you a nice pie chart that shows just where this plasma for fractionation is collected. Now, I'm just going to focus on plasma for fractionation, not plasma used for transfusion or any other usages in this entire presentation. And this pie chart shows, first thing you notice immediately is that 2/3 of the total source plasma and all plasma collected for fractionation comes from North America. And almost all of that North American plasma is from the United States. There's a bit in Europe, 14% of total plasma fractionation, 18% in Asia Pacific, and then almost nothing from Latin America and Middle East and Africa. at present. And I would note that in Asia, most of that 18% is coming from China, but it stays in China for reasons, for legal reasons. So plasma mostly comes from the United States for this industry. But where are the plants located? Where are the factories, the fractionation plants located? So here you have a visual depiction of where the number of plants are in the different regions, with the most being in Asia and Pacific. But most of those, about 25, are actually located in China. And they are small plants that only fractionate Chinese plasma. So even though it's the most number, it's not the biggest. Second biggest is Europe. This is for historical regions. There's quite a few plants in Europe back when each country had their own national program. North America, even though that's where most of the plasma comes from, has relatively few plants, but they are, for the most part, quite large plants, so they do a lot of volume per plant on average. So that's where the plants are, but let's look at actually the volume of plasma fractionated by a region. Now here you see a different scenario, and it alludes to what I said earlier, which is Europe, with its high number of plants plus quite a few large ones, fractionates the most plasma regionally. In 2018, this data shown here, 37% total. North America, which is almost all the United States, is just behind at 35%. And then Asia Pacific, over a quarter, most of that in China, but some other plants in East Asia as well. And then the Chinese plants can only fractionate Chinese plasma, because it's banned, plasma is banned from importation or exportation in China, so it's not part of the global flows. Then those other regions, almost nothing. So I've shown you the plasma mostly comes from the US, but then there's more plants in Asia and Europe than North America. So it stands to reason that probably quite a few liters of plasma needs to be shipped over. And that's actually what we see here. This is just looking at transfers of plasma from the US internationally. So not plasma that stays in the US and is fractionated, but plasma that is sent outside. And you see that the vast majority of plasma that's shipped internationally out of the United States, which is the dominant producer of plasma for this industry, is going to Europe. It's going to those 21 plants in Europe to be produced into the finished products, with a little bit in Asia Pacific and very little elsewhere. So that shows a little bit of the plasma flows. So now let's talk about product usage briefly. So the top pie chart here is the one you've already seen earlier, which is where plasma is coming from. This is the year 2018. 2/3 come from the US, and then some in Europe and Asia Pacific, and almost none elsewhere. The lower pie chart shows the usage of immunoglobulins, which is the most important product made from plasma by value as well as by volume. And you see here, North America is the largest consumer. The patients in North America use more than any other region, but it's less than half. It's certainly not closer to 2/3 of plasma collected, while Europe and Asia Pacific use around a quarter of the immunoglobulins annually. But you'll note that those regions and all the regions outside the North America collect a smaller percentage of plasma than immunoglobulins used. So therefore, these regions must import plasma from the surplus region, which is North America. And that is shown on this bar chart here. The blue columns show the amount of plasma needed for the immunoglobulins used by those patients in those countries. And the orange bars show the amount of plasma collected in that region. So if the orange bar is higher than the blue bar for a particular region, that region's collected excess plasma, and so some of the immunoglobulin made from that plasma can be sent to other regions. However, if the blue bar, so I'll say in North America, that's the case. The orange bar is bigger than the blue bar, with 57% more plasma collected than needed by the patients in that region. If the blue bar is higher than the orange bar, however, then what that means is that the usage in that region is higher than the percentage of plasma collected in that region, and there's a deficit of plasma, and so they therefore must import product from excess regions for the immunoglobulin usage in that country. For example, Europe and all the other regions have deficits. In Europe, it's a deficit of 38%, meaning about 38% of the immunoglobulin used by patients in Europe is imported from American source material plasma. So putting in together how plasma is collected, where it's collected, and then where it's shipped, and then where the products go after that, just focusing on immunoglobulins for a second. We have, I showed you already the white arrows, which are plasma from the US going to the other regions, which the dominant one is a plasma that's shipped internationally, it's shipped to Europe. But then the yellow arrows show where some of the immunoglobulin product is moved to other markets. And so in the whitest and biggest arrow, yellow arrow, is showing that after that plasma is shipped to Europe for fractionation, quite a bit of that plasma in terms of immunoglobulin product is returned and shipped back to the United States for usage in that market, or in Canada, which is the #1 consumer of immunoglobulins. The total global market for all plasma proteins is 24 billion, not just immunoglobulins, but all plasma put together. So this is a complicated slide, but I think it shows the complexity of this industry, that plasma is sent around the world and products are sent around the world. So before I wrap up, let's talk about a second protein made from plasma, which is albumin. It's generally considered the second most important plasma protein for therapeutic use. The top pie chart is the one you've already seen twice before, which is where plasma is collected by region. And the second bottom pie chart shows where albumin is used globally by region. And here you see immediately that Asia Pacific, which is mostly the Chinese market, uses more than half global albumin consumed globally. But the Asia and Pacific region only collects 18% of the plasma for fractionation. So the imbalance is clear. And in fact, where Asia Pacific gets a lot of that albumin, it is plasma collected from the United States, fractionated in the United States or in Europe, and that albumin is then sent to patients in Asia and Pacific, most of which are in China. So another protein with a different usage profile. So with that, let me just conclude. I hope from the data that you can see that most plasma for fractionation globally, on a global basis, comes from the United States, 2/3 in fact, of the plasma. That almost half of the plasma collected in the United States is sent overseas, mostly to Europe. More than 9% of that overseas is to Europe for fractionation. The rest of it is internally fractionated in those fractionation plants in the United States. Furthermore, that immunoglobulin products that are made from plasma fractionated in the United States and Europe are sent to patients around the world. But quite a bit of that product returns back to the United States and North America, which is the largest consumer of immunoglobulins regionally, globally. And then finally, that a lot of the albumin that comes from the United States plasma source originally is sold in Asia, with China being the dominant market in that region. So with that, I'd like to say thank you. If you have more questions about or interest in this space, this is my contact information. What we do is we cover this industry with data and market intelligence, and I'd be happy to hear from you. Thank you very much.
It was very helpful to see how the plasma flows around the world. All three of our experts did a great job sharing the complexity and also the safety of the plasma protein therapeutics manufacturing process. And as we saw, none of these critical therapies can be made without plasma, the vital starting material. So I just want to take a second to add PPTA's thanks to all of those generous donors and encourage all who can to become a donor. And with that, I'd also like to invite all of the panelists to come together to take some of your questions. Thank you all for some of the questions that have already been submitted throughout the presentation. So I am going to start by feeding some of those to our panelists. So we did get one question from Janine Parnell. She asked how long product is stored in the warehouse. And I was wondering, Michael, if you could cover that one for us.
Yep. Hopefully not too long. The shelf life of the products is also depends on the product. Could be 2 years, 3 years, up to 5 years. Yeah, what is the shelf life? And those products are really the cycle times, the throughput is really relatively quickly. We have a couple regulatory things which we need to follow. So, for example, when we collect plasma, we have a certain period we need to hold it before we could fractionate it. So, and those things. But in general, the storage in warehouse is something we try to avoid and limit to a minimum.
Great, thank you. The next I'm actually going to take a couple of questions that were asked that are sort of getting at a similar topic, and ask Matthew. Several of our attendees have asked how other parts of the world, other geographies can be more involved in the collection of plasma in this global journey, in all of these processes. And I wonder if you could share some of your thoughts on that.
Yes, Julia, that's a great question. There are a number of ways that countries or regions could participate more. As you saw in my slides, 2 whole regions contribute almost nothing to the global plasma supply. The first thing would be to make sure that the current plasma that's already collected as part of the whole blood collections, the Red Cross donations or whatever organization collects it in a country, is not wasted. And sadly, that is the case in a lot of countries. But there's reasons for that, such as the plasma may not be collected under the right conditions, there might not be the right kind of quality control mechanisms in place, or stored at the right temperature, etc. Or there might be legal restrictions. So if those could be changed to allow the plasma collected in countries around the world that isn't used for transfusion to be fractionated, that would be one easy way. Another step further would be to allow private plasma collection companies to operate in countries. As I showed briefly, the markets that do have those have a lot more plasma collected because there's a business incentive there, which makes a big difference. So those would be 2 ways, and then I'll stop there. But the fractionation side, there could be more plants built around the world also.
Thanks. We did get a question from, Sandy Adams, who noted that she is a user of subcutaneous IgG and was wondering where in nearby she could be referring, friends and family to, so that they could also donate plasma. And I wanted to answer that for the group. If anyone is interested in donating plasma, they can actually find the center closest to them through donatingplasma.org. And I, encourage you to check that site out and look at places where you can donate. All right, we've got a lot of questions coming in. I appreciate that. So then my next question is going to be from Leonid Perunov. This question is, can multiple products be made from the same plasma pool, and are different fractions from the plasma pool processed in parallel to make different products? I think, Michael, that's probably a question for you, if you want to go ahead.
That was, thanks for the question, great question. That was really what I would like to illustrate. So we have 1 liter of plasma where we have a huge amount of different proteins in. And with this process, we really purify the target proteins. So we could do out of 1 liter of plasma multiple life-saving therapies.
Thank you very much. We also received a question from Neil Gianelli in New York State. He notes that New York State allows people to sign up as organ donors when they get a driver's license, and wondered if plasma could be added to that list. I know we've had some back and forth in the Q&A, but I was wondering, Chuck, if you could elaborate a little bit on that and how and whether that can take place.
Yeah, so I do think as it was going back and forth in the Q&A, I did see a response from FDA around this. And it appears that a person may be confusing source plasma donation with tissue donation, which are regulated completely different. My suggestion is to look at the plasma-donation.org for some of the requirements for plasma donation, as well as making sure you understand the requirements that plasma for our purposes is from a healthy donor that is fractionated into other therapies. So, and you can potentially follow up with FDA on the regulation for tissue donations, which are obviously quite different than the source plasma regulations.
Thank you. Let's see. So we've got a couple of questions actually regarding what the testing is or ways to determine COVID antibodies in a product and whether we're seeing those or whether that is on the horizon. And I was wondering if anyone wanted to take a stab at that.
I would say something about COVID. So we have built together with other companies the COVID Alliance, where we especially motivated people which went through a COVID infection, which then normally build antibodies against the virus. And this COVID Alliance collected this so-called hyperimmune plasma with a high amount of antibodies against COVID, produced the final product out of it, and that's currently in clinical studies to see if this special product helps people to recover from the disease. So that's done, and we together with other companies within the industry, and that was really the first time we had built such an alliance together, and we fight it together. Even if we are competitors on the market together and develop together a product in our global network to fight the virus.
And then Julia, one other thing I'd like to add is it also created great awareness for plasma donation in general across the globe, and, you know, in regards to convalescent plasma, but it also allowed us to highlight the need for plasma for the other therapies that are needed. So I think it's a great opportunity, or the industry and the Plasma Alliance coming together to serve the need of the public, as well as creating awareness and understanding for the need for plasma donations for the other conditions that the products are needed for.
Thanks. The next one is a technical question from Susan North, probably for Michael. She said, it appears the bulk process is open and asks how sterilization is ensured.
So, as mentioned in the presentation, there are multiple steps. So with the picture you had seen that it was an early process in the step where we need to add a filter head or where we need to add some intermediates. And within the process, there's multiple steps. And before we do the filling of the products, there is a so-called sterile filtration with a 0.2 micrometer sterile filter. And we do also, during the process, continuously monitoring of so-called bioburden, and we have certain limits, and that's really secured that those products are safe.
Thank you. I think, Chuck, this one will be for you. This is from Andrew Baird. He said, I understand some US states, typically in the north, have more restrictive donation requirements. And, you know, could you talk a little bit about whether those do vary across the country or whether it's from between countries? Just give us a little overview of that.
Yeah, so there are obviously globally, there are different, I would say, eligibility requirements for each donor. I think in the US states, you may have some requirements around operating a plasma center, not so much in regards to the donation requirements, which I think PPTA has been very engaged in with the legislators on trying to reduce the burden for plasma centers to operate in those states to ensure that there's more plasma available to serve more patients.
And then related still to the way that plasma is collected in the US versus abroad, we do have a question whether the extra supply of plasma from the US is related to the fact that in the US donors are compensated. I don't know if Matthew, do you want to try that one?
Yeah, I'll jump in. Yeah, sure. So I didn't have time to fully discuss this, but most of the donation, over 90% of the volume of plasma fractionation comes from source plasma donors, which are apheresis, and over 90% of that source donor is collected through commercial organizations, most of that in the United States. But it's a good comparison to look at in between European countries. There are 4 countries in Europe that allow compensated plasma through private companies. Those 4 countries all collect much more plasma per capita than any other country in Europe that only relies on donated kind of national blood organizations to donate those. So yes, there's a very marketed difference in the amount of plasma collected per capita or by the population between places that legally allow commercial or private source plasma collection and those that don't.
Great, thank you. So here's another technical question. Michael, I think this is probably for you, but how long does the manufacturing process typically take from the beginning of base fractionation to packaging?
Thanks for the question. I would answer this in the following direction. It depends. Yeah, it really depends on the product. If you do further pooling of further intermediates, but to have the final product available, that could take between a couple of days until a couple of weeks.
So then let me keep looking. Sorry, there's lots of good questions. The next one I have is actually going to be for Michael and Chuck, and it's something I was hoping you could touch on, was whether, you know, in your careers spanning the last couple of decades, have you seen changes in the way your business operates, you know, due to the fact that this has become a more global industry? I'll let Chuck start if you want.
Yeah, sure. I've experienced this, that there's been a lot of changes, you know, from the kind of isolated aspect to the global nature of the business. And I think there's a few things that in our operations that have changed, you know, through that process. I think there's more harmonization, not only from a regulatory requirements and information sharing between the regulatory authorities, but there's a lot more harmonization across the businesses between how we do things globally than we did previously. So equipment standardization, different processes around that, as well as staff training and different pieces like that, as well as I think the PPTA, IQPP standards have kind of expanded globally as well. You know, in that time frame. So there's a lot of changes that have taken place, and I think it's helped our industry become better throughout the long run. So.
Also, digitalization transformation had happened. So when I started in the industry, we still had donor sheets, so on paper, yeah, and we reviewed the barcodes and double checked it visually. That's all electronically today, yeah. So everything is tracked with the software, and it's through this. And on the other hand, really the globalization and building up the networks increase the efficiency of the business. Yeah. So really, we are interconnected, work close together, and have a certain scale of operation, and not having a lot of individuals here, individuals there. They are specialized here and specialized there. So it's really a great thing to have such a interconnected network working together to deliver those life-saving therapies to our patients.
Thank you. Let me see. So there's a lot of questions. Matthew, we've got more questions coming in, wondering why there are not more donation centers in for example, APEC countries or South America. If you want to give a little more detail on any ideas you have about that, that would be great.
Sure. Yeah. I see those questions. Those are good questions because it doesn't make sense. It doesn't seem very logical. But as with a lot of things in a highly regulated industry, it's mostly the regulations in the countries that have resulted in this outcome. That's why I mentioned if regulations change, then there can be different outcomes. For example, just to speak of a very large country in Asia, India prohibits all sort of source plasma collection to be used for fractionation. It just can't be done. It's not legal. So obviously companies cannot set up plasma collection centers in India. It's not allowed. If those rules were to change, then I'm sure there would be, and then there would be more plasma collected in India. That same situation is applies to many countries around the world. I would say most of the Latin American or South American countries have that, where they prohibit plasma collection or apheresis collections to be used for fractionation, or it can only be done by the national nonprofit organization. So that would be the primary reason. There's no biological or health reason why it couldn't be done other places. It's usually legal and regulatory.
Thank you. All right, I'm gonna turn to you, Chuck, with a good question. Jerry Venable asks, what have the challenges been with donor collections?
Yeah, so recently I would say, you know, with the collection process in the pandemic environment, it's not unlike any other business that have had challenges in regards to their operations. So we've definitely seen an impact. We've put in, I would say, controls in place for physical distancing, safety measures, additional cleaning, different processes around that. In addition, I would say that, you know, as donors are kind of restricted in movement, it was very essential for us to have plasma donations designated as essential business so that our employees could get to work and participate in the collection of plasma, whether it be for convalescent plasma with the Plasma Alliance or just normal source collection. So that was really helpful for us, working with, I would say, the different local health departments and governments on contact tracing and reporting different aspects of that. So those are some of the challenges in getting donors back into the routine of coming out and participating in our programs is continues to be what we're working on. So.
Great. And I don't know, Matthew, can you speak to any of whether those challenges are seen in other parts of the world, or, you know, any international point of view you've got there?
Just to clarify, challenges on the plasma collection side or the COVID side? I wasn't sure your question.
On the collection side.
Yeah. Okay. Yeah. I mean, with the pandemic, there's been definitely challenges in many places, different places, different issues, but it's affected almost everyone. But different countries have gone through different phases at different times, so it hasn't been the same month everywhere. It was affected evenly. But just more broadly, yeah, it's a challenge to recruit donors generally, especially since plasma donation is something that you can donate frequently, unlike whole blood. It's not something where you can donate only 2 or 3 times a year. You can donate in most places around once a week or even more frequently. So that's a lot to ask if you can donate that much to get donors to come in 10, 20 times per year, which really adds a lot of volume to the overall pool that patients need. And so I'd see there's challenges there.
All right, thank you. So I think we're coming to the end. I'm going to ask maybe 2 more questions. I have a question for Michael, and Petra Iwala is asking how long COVID antibodies, and I think it'd be interesting to hear about other antibodies as well, will stay in plasma and an immune globulin. And will it be, you know, how long does some of that protection last?
That's a very good question, and I really could not answer this specifically. There's, especially for COVID, not enough data available. And it really depends, and it's not only the antibody, it's also the memory cells, which are part of the immune system and so on. So it's really a very complex question, which could not be answered so easily. And especially for COVID, there's not much data yet available to give here a precise feedback to this. For other antibodies, there are better data available, but in general, you could say the half-life time of an IgG is roughly 23 to 27, 28 days. So that's roughly what you could say. But the immune system is a little bit more complex. It's not only the antibodies.
Thank you. I am going to ask one more question, but in the meantime, while we do that, we actually have a poll that we're going to put up for all of the participants to answer. And while, you know, we get that question answered, people can start taking a look at that and providing us with a little bit of feedback. So I think the last question here is from Kyle Reed, or Kylie Reed, I'm sorry. She said probably for Chuck, and then happy to hear anyone else's thoughts on this, but what is the best way to create a sense of connection between donors and patients that receive those therapies?
Yep. Well, thank you. That's an excellent question. We do a variety of, I would say, mechanisms to connect the patients to the donors. We have a lot of material in our centers. We have patients that actually visit the sites. In addition, we work with within the community to make people aware of the patients and as well as the therapies they need. So there's a lot of different activities on doing that. I don't think there's one best way. I think you need to explore all the channels to make sure that you create awareness for the patients and the plasma business.
And I would like to underline this. It's, as mentioned in the presentation, it's a people-to-people business. And the best way is to bring those people together. So we do it also routinely, having patients talking to our people on the sites, in the plasma centers, in the production sites. And really, that's really the unique of our business, that we know our patients. That's really, with the rare diseases, something which is important. And it's also, and I saw one comment here where there was a PID patient who thanked also the industry and all the people working in the industry, that we do all the work to deliver the life-saving therapies. And that's really something which is good for the people, but on the other hand, also for our donor, for our patients, a good opportunity to say thank you.
Absolutely, thank you. So before we end, I want to give all of you the chance, if there's anything else, any points you wanted to make in addition, please chime in.
Only a little advertisement. Next week, 28th of February, is Rare Disease Day. Watch out for it.
Yes,
and
thank
you. I would just like to say thanks to everybody involved in the industry, from the donors to the employees to the regulators. You know, we all are in this to do the right thing and make sure that people have a great experience and can help someone out in the process and serve more patients. So thanks to everybody that's contributed in some way or another.
I'll just add, thank you for all the questions, for all the people listening, paying attention, asking good questions. They were very interesting and well thought out.
Yes, absolutely. Thank you very much. And thank you to the three of you for taking the time to do this. This was very informative. We appreciate it. If there are other questions that come in, you know, afterwards, we'll make sure to send those out. And thank you for filling out our poll. And with that, I'm going to also, again, lend PPTA's thanks to all of the donors out there helping to keep, you know, product coming and, you know, helping treat patients. And we appreciate all of our, you know, members and stakeholders for continuing to make forums like these useful. So thank you, and I hope everyone has a great day.